Hi everyone. So today we'll continue our discussion of logarithms. So today we'll be studying a new topic which is the laws of logarithms. So there are basically three or four laws, like there are 3 to 4 laws which we'll be studying to which will help us to solve logarithms. Okay. So I'll just explain it through an example. So suppose we have a log of xy to the base of a. Okay, we have this log. So there's one law which is known as the multiplicative law, So what it states, this law states when we have a log of this form, log of x into y to the base a, this can be written as log of x to the base a plus log of y to the base of a. Okay. So this is our multiplicative law of logarithm. So any log which is of the form log of xy to the base a, it can be written as log of x to the base a plus log of y to the base a. So we'll just take an example. Suppose we have log of 8 plus log of 2. Okay, so we are just asked to find the value of these logs. So we have to just simplify this expression and we have to find the value of this log. So by this law, by multiplicative law, the value of this log will be log of 8 into 2, which is equals to log of 16. So you can find out the value of log 16 with the help of your calculator. Okay, so since we are just asked to simplify it, we can just leave it like this. If you are asked to find the value of this expression up to 2 or 3 significant figures, then you have to solve it with your calculators. Okay, so we'll just apply this property, we'll just apply this law in this question so that we can get the answer. Okay, so this is your first law, which is the multiplicative law of logarithms. Now there's another law. Since we have covered multiplication, so there must be a divisive law also. So there's a division law. The division law states that whenever you have an expression of this form, log of x by y to the base of a, okay, log of x to the x upon y to the base of a, the value of this expression will be log of x to the base a minus log of y to the base a. Okay, so this is your division law. This is your division law. Division law of logarithms. Okay, if the terms are multiplied, if your argument is in the form of multiplication of two numbers to the base of a, then we'll just separate the numbers and we'll add the logs. And if the numbers are in division, so we'll just subtract it. We'll just separate the numbers and we'll subtract the logs. Okay, so we'll just take an example of this also. Suppose we have to simplify log of 15 to the base 4 divided by log of 5 to the base 4. We have to simplify it and we have to find the expression for this. Okay, so if we'll apply division law in this, the value of this will be log of 15 by 5 to the base of 4. Okay, so this will become log of 3 to the base 4. Okay, oh actually sorry, we have just like misprinted it. It's not division, it's subtract. Okay, it's written wrong. So log of 15 to the base 4 minus log of 5 to the base 4. So when we'll apply division law in this, it will become log of 15 divided by 5 to the base of 4. Okay. Two logs are subtracted with the same base, then we get this expression. Okay. So if you're asked to simplify it, you'll just leave it like this. And if you're asked to write the answer up to 2 or 3 significant figures, then we'll use your calculator. Okay. So this is your division law. Now there's one more law which we'll be studying. So that law, the third law, it is the power law. It is the power law. What is the power law? Suppose we have an expression log of x to the power of m and we have the base as a. Okay, we have an expression like log of x to the power of m with the base a. Then this can be written as, this m will just shift here to the left of the log. So m log x to the base a. So this is your power law. In power law, if you have an argument which is in the form of an exponent, then we just shift the exponent to the left side of the log and then we'll write the expression as it is. Okay. So suppose we'll just take an example. Suppose we have an expression like 2 log 4 to the base 3 plus 5 log 2 to the base 3. Suppose we have this expression and we are asked to simplify this expression. So by using power law, we can write, see, this term is the exponent of this. Okay, so we can write it as log of 4 square to the base of 3 plus this term is the exponent of 2 plus log of 2 to the power 5 to the base of 3. Okay, so we know this by power law that the powers are just shifted. Okay, so now this can be written as, now can we apply multiplicative law of logarithm in this form? Because they are in addition with each other. So we can write it as log of 4 square is 16 into 2 to the power 5 is 32 to the base of 3. What we have done here, we have just, okay, we'll just simplify it more. Log of 16 to the base 3 plus log of 32 to the base 3. Okay, and now we have applied the multiplicative law of logarithms. So because the logs are in addition, so we have just multiplied it. Okay, so log of 16 into 32 to the base 3, this will become log of 512 to the base 3. So this is the simplified form of this expression, Okay, so there are basically three laws. One is the multiplicative law, second is the division law, and third is the power law. So you just have to remember this because when you will get expressions to simplify or to solve, you have to use these laws. So you can simplify the expression. Now there's one more concept that we'll be studying. Suppose I take an expression log of 1 upon x to the base of a. Okay, if we take this expression, so we can write this expression as log of x to the power of minus 1 to the base a. Okay, we can write 1 upon x as x to the power of minus 1. So by using power law, if we shift this minus 1 to the left side of the log, this will become minus of log x to the base a. Okay, so we just get one more important result, that log of 1 upon x to the base of a is equals to minus log of x to the base a. This is a very important concept that you can just remember so that it is easy for you to simplify and solve problems. Okay, so let's consider some more examples so that you will get a clear understanding of what we are doing here. Now there's one question. Okay, the question is, you are given that log of p to the base 5 is equals to x. You are given that log of p to the base 5 is equals to x and log of q to the base 5 is equals to y. You are just given with these information and you have to express some algebraic expressions in terms of x and y. You have an expression log of p to the base 5 plus log of q cubed to the base 5. You have to express this expression in the form of x and y. Okay, have you understood what's going on? We are just given with this information that log of p to the base 5 is equals to x and log of q to the base 5 is equals to y, and we have to express this expression which is part a in the form of x and y. So what we'll do here, this is log of p to the base of 5 plus. Now we'll apply power rule over here. So what is the power rule? That the exponent will shift to the left side of the log. So it will be 3 into log of q to the base 5. Okay. Now we have to express it in the form of x and y. So we know that log of p to the base 5 is x. So this is x. And log of q to the base 5 is y. So this is 3y. Okay. So have you understood what we have done here? Okay. So let's take one more example. Suppose we have to express log of q by 5 to the base 5 in the terms of x and y. You have to convert this in the form of x and y. So by division law, we can write log of q to the base 5. Since it is division, so we'll subtract the logs. Minus log of 5 to the base 5. Okay. So what is log q to the base 5? Log q to the base 5 is y. Okay, y minus, and now we know that the value of log 5 base 5 is 1. So this is y minus 1. Okay, so in this case, we are just writing our expressions in the form of x and y. So we apply the laws of logarithms in solving these type of expressions. Okay. So there are certain questions which are asked in your examination or in your papers where we just have to solve the expression in the form of x or y by applying the laws of logarithm. Okay, so there are certain questions which have been asked in your papers. So we'll just take an example of one question which has been asked in your GCSE additional mathematics paper, whose code is 0606. Okay, so we are given that log of x to the base p is equals to 5 and log of y to the base p is equals to 2. Okay, we are given with this expression. We are just given with this information that log of x to the base p is equals to 5 and log of y to the base p is equals to 2. And we have to find the value of log of x squared to the base of p. Okay, so this question came in your GCSE, this question came in your GCSE paper of 2013. This came in your GCSE paper of 2013, additional mathematics paper 21. Okay, the November session. It came in the November session. So we are given with this information and we have to find the value of this expression. So what we'll do here, we know that if we'll apply power rule over here, so we have to express it in terms of, like, we have to find the value of this. So by using power law, we can shift this 2 to the left of the log. So this will become twice of log x to the base p. Okay. So now we know that log x to the base of p is 5. So we'll just substitute the values. So this will be equal to 10. Okay. The answer will be 10. We have used the power law over here. Okay. So this was the question which came in your GCSE paper. There was one more part of this. So we'll just solve that also. The next part is log of 1 upon x to the base of p. Okay. We have to solve this and we have to find the value of this with the given information. So we can write it as log of x to the power of -1 to the base p. We can write it like this. Okay. Now, if we'll shift this power to the left of log, what will it become? It will become minus of log of x to the base p. Now, what is the value of log x to the base p? It is 5. So the answer will be -5. Okay. So these are the type of questions. These type of questions are asked in your paper when where you're given with certain information and you are asked to simplify or find the value of the logs. So we can do it with the help of all the laws of logarithms.